A very good day to you all. Myself Damodar Rao. Today I am here. Today I am here to present my internship project titled Smart Factory Monitoring System. This project is based on the concept of Industrial Internet of Things, where sensors and devices are connected to monitor and control systems in real time. The aim of the project to build a system that can continuously monitor factory conditions and help in improving efficiency, safety, and automation. In this presentation, I will explain the problem, the proposed solution, system design, and how the system works in real time. Let us come to the introduction of my project. In modern industries, the concept of smart factories is becoming very important. A smart factory uses IoT devices and sensor to monitor operations continuously instead of relying on manual inspections. Data from machines and environment is collected in real time and sent to central systems. This helps in improving efficiency, reducing errors, and making faster decisions. Overall, smart monitoring plays a key role in modern industrial systems. Coming to the problem statement, in traditional systems, monitoring is mostly manual. Operators need to check machines physically, which is not continuous. Because of this, problems like overheating or abnormal vibration may not be detected immediately. This leads to delays, increased maintenance cost, and safety risks. So, there is a need for a system that can monitor continuously and provide instant updates. So, need for IoT and automation is to solve these problems, industries are moving towards automation. IoT allows devices to communicate and share data in real time. This enables continuous monitoring without human involvement. It also helps in detecting faults early, which prevents major failures. So, automation improves efficiency, reduces cost, and enhances safety. Coming to the objectives of my project, the main objectives of this project are to monitor factory conditions in real time, to send data to the cloud for remote access, to implement automation based on sensor values, to improve safety by detecting abnormal conditions, and to allow remote control of devices. Overall, the goal is to build a smart and reliable monitoring system. The scope of my project is the system can be used in different environments like factories and warehouses. It is scalable, meaning we can add more sensors and nodes easily. In the future, it can be extended with advanced features like AI-based monitoring and mobile applications. The proposed system is it mainly contains two nodes. The first node is used for monitoring the production line where machines are operating. The second node is used for warehouse monitoring, focusing on environmental and safety conditions. Both nodes collect data using sensors and send it to the cloud. Users can monitor the data and also control the system remotely through a dashboard. Here is the system architecture. In the system, sensors collect data such as temperature, humidity, motion, and vibration. This data is sent to the Arduino controller, which processes it. The Arduino that sends the data to cloud using a Ethernet connection. MQTT protocol is used for communication. The cloud displays the data on dashboard, where users can monitor and control the systems. Now, hardware components are the system uses Arduino UNO as the main controller. DHT22 and LM35 are used for measuring temperature and humidity. PIR sensors detect motions and LDR detects light intensity. The vibration sensor used to monitor machine condition. Relay is used to control devices and LED indicates system status. The Ethernet module is used for internet communication. Now, software and technologies which are used in this project are, for software, Arduino IDE is used to write and upload code. MQTT protocol is used for communication between the device and the cloud. ThingsBoard is used to visualize data and control devices through a dashboard. Proteus is used to simulate the system before implementing it in hardware. These technologies together enable the complete working of the system. Now, modular firmware design is, in this project, it is designed in a modular way. This means the code is divided into different sections, each handling a specific task. One part of the code reads sensor data, another processes the data, and another manages communication with the cloud. There is also a controller module that handles relay operations. The system is programmed to send data at regular intervals, ensuring continuous monitoring. This modular approach makes the system easier to maintain and upgrade. Now, coming to the Node 1 overview, Node 1 is responsible for monitoring the production line. It focuses on tracking machines, conditions, and environmental parameters. The node continuously collects data and sends it to the cloud. This allows user to monitor the production line remotely. It helps in detecting problems early and maintaining smooth operations. Overall, Node 1 plays a key role in machine monitoring. Now, Node 1 sensors and components are here. Node 1 uses multiple sensors for monitoring. The DHT22 sensor measures temperatures and humidity. The LM35 sensor provides more accurate temperature readings. The vibration sensor detects machine condition and helps identify faults. A button is used to represent machine status. A relay control external devices and LED indicate system status locally. Now, Node 1 working principle is here. In Node 1, the system continuously reads sensor data. The Arduino processes this data and prepares it for the transmissions. For every 5 seconds, the data is sent to the cloud. The system also checks for conditions like high temperature or vibration. If any abnormal condition is detected, action can be taken. Relay can also be controlled automatically or manually. Now, Node 1 telemetry and monitoring is here. Node 1 sends telemetry data to the cloud. This includes temperature, humidity, vibration, and machine status. The data is updated continuously, allowing a real-time monitoring. The system also supports RPC commands. Using set relay, we can control the relay, and get status is used to check system status. This enables both monitoring and control. And here we are for Node 2 overview. Node 2 is designed for warehouse monitoring. It focuses on environmental and safety conditions. It can detect motion, monitor humidity, and track door status. Like Node 1, it sends real-time data to the cloud. This helps maintain safe and controlled storage conditions. Node 2 sensors and components are here. The Node 2 uses several sensors for monitoring. DHT22 measures temperature and humidity. LDR detects light levels, which helps identify day or night conditions. PIR sensor detects motion for security. Door sensor tracks whether the door is open or closed. Relay and LEDs are used for control and indications. Now, Node 2 working principle. Node 2 continuously monitors environmental and safety conditions. It collects data from sensors and processes it using Arduino. The data is sent to the cloud at regular intervals. It can detect motion and door status changes. If any abnormal activity is detected, alerts can be generated. This helps in improving security and monitoring. Node 2 telemetry and safety functions. Node 2 sends telemetry data including temperature, humidity, motion status, and door status. This data is updated continuously and displayed on the dashboard. It helps in monitoring both environmental conditions and safety. For example, if motion is detected in a restricted area, it can trigger an alert. This is how it works. So let us move to the next slide. Automation, humidity based relay control. One of the important features of this system is automatic relay control. When humidity crosses a predefined threshold, the relay is activated automatically. This ensures proper environmental control without manual effort. The system continuously monitors humidity levels. This feature improves efficiency, helps maintain optimal conditions. It also reduces energy wastage by controlling devices only when needed. Coming to next slide, manual override and RPC control. In addition to automatic control, the system supports manual control using remote procedure calls or RPC. RPC allows the cloud to send commands directly to the device. The set relay command is used to turn the relay on or off manually. The set auto command is used to enable disable automatic mode. The get status command helps retrieve the current system state. This feature provides flexibility, allowing the user to switch between automatic and manual control depending on the situation. Now, MQTT and ThingsBoard communication flow. The communication between the device and cloud is done using MQTT protocol. MQTT works on a publish-subscribe model. The device publishes data to the cloud and the cloud subscribes to it. Similarly, the cloud can send commands back to the device. This protocol is lightweight and efficient, making it ideal for IoT applications. It ensures fast and reliable data transfer with minimal delay. Now moving to the next slide, LED status indication and local feedback. LED indicators are used to provide local feedbacks about the system. They show whether the system is powered on, whether the relay is active, and if any alert condition is present. This makes it easy to quickly understand system status without checking the dashboard. It also helps during the debugging and testing. Next slide is about Proteus simulation environment. Before implementing the system in hardware, we use Proteus simulation software. This allows us to design and test the circuit virtually. We can verify connections, test logic, and ensure everything works correctly. Simulation helps in reducing errors and saves the time during actual implementation. This step is very important for validating the system design. Now, here is the next slide, dashboard visualization and remote monitoring. The ThingsBoard dashboard is used for visualization and control. It displays real-time sensor values in the form of graphs and indicators. Users can monitor temperature, humidity, motion, and other parameters. Alerts can be displayed when condition exceeds limits. The dashboard also provides control to operate the relay remotely. This makes the system user-friendly and easy to manage. Now, end-to-end data flow is here. The data flow in the system starts from the sensor collecting real-world data. The Arduino processes the data and sends it to the cloud using Ethernet or MQTT protocol. The cloud stores and displays this data on the dashboard. Users can view the data and send commands back to the system. These commands are received by Arduino and executed, such as turning the relay on or off. So this completes the full communication loop. Coming to the key functionality summary, the system provides several key functionalities. It supports real-time monitoring of environmental and machine parameters. It also remote access through the cloud dashboard. Automation is implemented for efficient control. Safety alerts help detect abnormal conditions. Two-way communication enables both monitoring and control. The system is also scalable for future expansions. Now, advantages and industrial benefits are here. For my project, the system offers several advantages. It increases efficiency by automating monitoring tasks. It reduces manual work and human errors. It improves safety by detecting abnormal conditions early. It is cost effective compared to traditional monitoring systems. It also helps in better decision making using real time data. Overall, it provides a scalable and reliable solution for industries. Now, coming to the limitations and future enhancements, the system has some limitations, such as it depends on internet connectivity for cloud communication. It also has hardware limitations based on the components used. However, in the future, the system can be enhanced by adding AI-based predictive analysis. It can also be integrated with the mobile applications for easier access. Wireless communication can replace Ethernet for better flexibility. Advanced analytics can further improve performance. Now, let us see the demonstration of the project. Let me open my project. Yeah, here you can see. Now I will demonstrate my smart factory monitoring system. The system consists of two nodes. Node 1, a production line, and node 2, a warehouse. Both nodes sends real-time data to ThingsBoard Cloud using IoT. Coming to node 1, a production line. This is node 1, which represents the production line. Here we have the following components like DHT22, it measures temperature and humidity. LM35, additional temperatures monitoring. Vibration sensor detects machine vibration. Machine control LEDs shows machine status on or off. Relay used to control machines. Now, when I change the sensor values, the Arduino reads these values and sends them to the cloud. Here we can see DHT22. There are temperature and RH values. Whenever we change these values, we can see the change in the temperature gauge. We can see the change of temperature in temperature gauge. Here we have set into temperature for 13.4 and RH for 22%. The changes can be appeared in the dashboards of ThingsBoard Cloud. Yeah, here we can see the temperature gauge is set to 13 and humidity gauge is set for 22. So let us move to the next thing. If I open latest telemetry, you can see a real-time data like temperature is equal to 28 degrees. This confirms that node 1 is actively sending data. Now this is a production line dashboard. Here we have temperature gauge as I showed you. It shows current temperature. Humidity gauge shows humidity level. Time series chart shows real-time data trends. A table stores historical data. It stores the data of past 30 minutes. machine status and relay state. Now we also have an alarm system. For example, if temperature exceeds a limit, a critical alert is generated. This helps prevent mission failure and improves safety. Here we have switch control. Using this, we can remotely turn on or off mission. This controls the relay in real time. Here we can see a switch control is off. Whenever we turns it into on, we can see the changes here. The indicator shows the on symbol, which is indicates a red in color. Whenever we turned it off, let me show you. You can see, you can clearly see here the indicator shows off symbol. This is how the switch control works. So node 1 demonstrates monitoring, alerts and remote controls. Coming to node 2 warehouse. This is node 2. Yeah, this is node 2, which represents this warehouse monitoring system. The components used are DHT20. Let me show you. Yeah. The components used are DHT22, a temperature and humidity. It measures, of course. LDR detects light intensity. Door motion sensor detects movements on door status. Relay controls warehouse devices. LED status indicates. Let us see how DHT22 temperature and humidity measurement devices works. We can see here the temperature is set for 20.6 and the RH value is set for 38%. Yeah, you can clearly see here the temperature gauge represented the 21 degrees of Celsius and as well as RH value which measures the humidity as shown as here. It showed 38. This is how the DHT22 works in for node 2. Now in ThingsBoard, the node is represented as warehouse 2 devices. If I open telemetry, we can see live data like temperature, humidity and light status. This is warehouse monitoring dashboard. Here we have, yeah, you can clearly see here. Here we have temperature gauge, humidity gauge, LDR value, which detects the light, and time series graph and data table. Like that. Again, we have a switch control here. It also works similarly to the node 1. If you turned it on, we can see the relay status is an on. And if we increase the RH value to 100% degrees, which indicates the more humidity, and if you decrease, we can decrease it to the 33%. In such a way, the switch also works here. Again, if we turned it off, you can see the change, and even the we increase the humidity to 99%. We can see changes. The indicator is not showing any issue. Coming to devices in ThingsBoard, here we have, let me open. Yeah, here we have production line node 1 and we have warehouse 2 node 2. Each device have receives telemetry data, stores it in cloud, sends it to dashboards. Here we have smart. Yeah, here we have smart factory overview. The node 1 data and node 2 data are clearly displayed here. You can clearly see humidity, door open status, is it dark or it's a day, IDR values, motion detector, temperature, sensor errors, relay status, etc. Such as attributes such as humidity, machine status, temperature, relay status, vibration can be clearly seen here with a time series chart. All the data will be updated here. You can clearly see temperature and IM35. This is how the smart factory dashboard works, and each dashboard includes gauges, as I said. charts, tables, switches, and alarms. Now here final working summary. So overall, sensors collect data, Arduino process it, data is sent to ThingsBoard Cloud, dashboards display real-time values, alerts are generated automatically, devices can be controlled remotely. The system enables smart and efficient factory monitoring. This is how the project demonstration will be. So that's all for my project. And in conclusion, this project successfully demonstrates a smart factory monitoring system using IoT. It enables real-time monitoring, automation, and remote control. It improves efficiency, safety, and overall performance of industrial systems. With future enhancements, it can become even more powerful and widely applicable. Okay, and that's all. Thank you for your time and attention. Thank you. Thanks a lot.